Let's look at some Earth system observations. Of course, we always have to start with the Keeling curve, which started in the 50s, as we've seen already several times, and we will see again several times. Shows this breathing of the planet, which we will visit again. Basically, spring, summer months, when sun comes into the hemisphere, vegetation begins to photosynthesize. Those that are deciduous and so on start shedding leaves in fall, winter months. Photosynthesis dies down, and the uptake by the terrestrial biosphere is reduced. So the concentration in the atmosphere increases, and you can see that here as a seasonal cycle, right? You are creating a range of about 4 ppm or micromole per mole of CO2 variation on a seasonal time scale, and there is a steady trend over it corresponding to the fossil fuel burning and other contributions by human activities. We will see that if you remove this trend and then look at the time variability, you actually also see fairly significant variations from year to year because of terrestrial changes in terms of temperature, rainfall, droughts, for example, associated with El Nino, which we haven't defined yet. And because of volcanoes, ocean changes, etc. Okay, so associated with that burning of fossil fuels, there is a signature in the oxygen as well. So this is showing oxygen per meg. So it's not tremendously significant in terms of the amount of O2 there is in the atmosphere, almost 21%. So nonetheless, it's consistent with the fossil fuel burning that uses up oxygen. And surprisingly, Charles Keeling was the one who started the CO2 measurements, and his son Ralph Keeling runs this oxygen measurement from Scripps Institute of Scripps Institute of Oceanography in San Diego. Okay. Of course, methane is going up as well, with not as strong a seasonal cycle, but still there is a strong seasonal cycle associated with rice agriculture, rice paddies, wetlands, cattle, and so on, which have a seasonal cycle. The wetlands, for example, and rice paddies have seasonal cycles as well. And there is some flattening in the middle here, which is not fully explained. There is a similar trend in N2O. Only thing to remember is that these are in parts per billion or nanomole per mole as opposed to micromole per mole. So here is shown in parts per billion by volume. So you can see that that also has gone is going up fairly steadily. Sources again being industries, agriculture, and so on. Terrestrial biosphere is now routinely monitored by satellites. We'll visit this in a little bit more detail, but basically photosynthetic pigments in leaves or in the algae in the ocean absorb in the red, and that leaves other spectra being reflected that can be measured from satellite, looking at the radiances coming from the surface using spectral radiometers. And this is a nice seasonal cycle rendition from CWIF's satellite, which went up in 1997 and died somewhere in 2011, I think. Here comes the chopper, so let's wait a second. When we talked about the atmospheric circulation, we mentioned the ITCZ, the Hadley cell, and the moving of the warmest waters with the sun. Entire ITCZ moves as well, as we saw, and that also corresponds to upwelling or divergence of water from the equator because of Coriolis effect being different on either side. bringing up cold, nutrient-rich waters, and similarly waters diverging away from the coasts, bringing up nutrients. So if you have enough nutrients and enough light in the so-called euphotic zone, you get photosynthesis, so you see a strong seasonal cycle there. But if you looked at interannual variability, you would also see things like El Nino and La Nina, which affect the productivity. At higher latitudes, there is typically what are called spring blooms. So the winter light is not enough, and the surface layer gets colder and heavier and mixes down, creates what is called a surface mixed layer with turbulence mixing. The waters get deeper, so there is not enough light, even though there are nutrients to drive photosynthesis. But as soon as sun comes up over the horizon in the spring months, the light availability and the warming, creating the shallowing of this turbulent mix layer, concentrates the nutrients in the euphoric zone, and you get a very strong bloom at high latitudes, both in the southern hemisphere and in the northern hemisphere. There are lots of interesting ecosystem cascades involved with that, including whales going all the way from the northern hemisphere to the southern hemisphere to feed on krill and so on. But there is also obviously a very strong carbon cycle, carbon uptake associated with that. You see the rainfall season over land as well, in terms of the waxing and waning of the greenness and photosynthesis on land. So this is a beautiful Earth system observation from satellites. Associated with that, excuse me, there is a doorbell ringing. The other important Earth system observation, of course, is the global mean temperature increase, and these are various products from different centers: NASA Goddard, NOAA, Hadley Center in the UK, Berkeley Earth Project, and so on. And you can see that all of them show anomalies with respect to the base period of 1951 to 1980. So these are averaged over the whole globe. The distribution of data is not even, and it's not as good when you go back in time, but nonetheless there is fairly high confidence with these multiple constructions, and there is a lot of satellite data going into this in the later periods after 1980 or so. And you can see that the before about 1940, the global mean anomalies were below the base period. They hovered around the base period from the 1940s through about the mid 1970s, and then the warming has been fairly steady and increasing. Obviously there are ups and downs, which are the so-called natural variability that we will talk about. So global temperatures are now controlled not only by natural variabilities like El Nino and La Nina and other modes of variability that we will talk about. Depends on how much energy is going into the ocean, how much is being used up for melting the glaciers, evaporating the oceans, and so on. But the increase, especially the decade-to-decade warming, is very clear despite the ups and downs each year. Okay, so we will continue this in a minute into the next podcast. We'll look at a few more observations, but earlier we looked at the satellites, ocean observations, and so on. Now they're all being combined to look at the Earth system, including the atmosphere, cryosphere, hydrosphere, some of the lithosphere, and of course the biosphere. Okay.